Good evening, learners. You are welcome back to our mathematics class for today. In today's class, we want to start a journey on a special topic called sets. I call it a journey because we need a lot of explanation before coming down to the calculation aspects of sets. If you are just joining us for today on our channel, kindly subscribe to my channel and don't forget to click the notification bell for my subsequent contents so that you can be seeing our subsequent contents. To my, to my usual family on this channel, I say thank you for believing in us, for providing you with evergreen contents. But don't forget to share, like, and leave a comment as you move on this channel. Always give me a love emoji so that other people can also benefit on this channel. So let's dive in. Set. What is a set? A set is a collection of a well-defined objects. Look at that word, well-defined objects. When we have a collection of objects that are well defined to a particular thing, to a particular name, we refer it to as a set. Say for instance, a mathematical set. A mathematical set contains a lot of objects in it. This mathematical set, the collection, is what we refer to as our set. For example, looking at this mathematical set, it contains a calculator and a mathematical set. In it, we have a lot of things. We have an eraser, we have a pencil, we have a protractor, we have the T set, we have the set, we have the ruler, we have the compass, then we have the divider. So all these elements in this box are the members of this set. So a mathematical set is a set. Why those elements, the materials, the objects that make up that mathematical set they are referred to as elements of the mathematical set. Element of a set, or we call it member of a set. Also, in a single school, we have different classes. For instance, SS1 classes. We can have SS1 Arts, SS1 Commercial, and SS1 Science. In each class, we have some members of the class, the students in that class, with different names, different surnames. All these students in this class, they are the members of that class. For instance, those students in the science class are the elements of science. They are the members of science. So in this case, a set is denoted with a capital letter, while the members of that set, they are denoted with small letter. Look at this. Set A is a mathematical set. Why this A contains ruler, pencil, protractor, divider, compass, and so on in it. So these are the elements of the set. Why this capital letter represents that set what? Set A. Let's look at the elements of a set. As I explained earlier, the elements of a set are the members of that set. The members that make up that set. Example 1. List the elements of the set. A. Even numbers less than 50. And B. Natural counting numbers. Now, we want to list the elements of this set. Set A. Even numbers less than 50. We know what even numbers are. they are number that can be divided by 2 without no remainder. So they start from 2 and start increasing by 2. And that even number must be less than what? 50. So we have 2, 4, 6, 8, 10. But because I don't want to start listening, since they say it is less than 50, meaning that the last number will be less than 50. So when you take away 2 from this 50, we're going to have 48. So the last number here is 48. So these are the elements of a set what? A. Okay, set B. Natural counting numbers. Natural counting numbers are our number 1 to infinity. So we have 1, 2, 3, 4, 5, 6. So because I cannot list all the whole elements, I have to put 3 dots to show that the elements are still going. So we still have some elements in this place. Likewise here, we have some elements here before we get to what? 48. So all these 1, 2, 3 and so on, they are the members of the set B. And or we call them elements of set B. Let us look at this short subheading: belong to, not belong to, or is a member of and not a member of. If you can recall the example we just gave, that set A is equals to 2, 4, 6, 8, 10, and so on to 48. Are we there? Now, if you now look at this, 2, 4, 6, and so on, they are the members. I can say that 2 belong to set A. So this symbol means a symbol of belong to or member of. So which means that this 2 is a member of set A, or it belongs to set A. Likewise, what if I say 9? Is 9 part of this number? Definitely not. So 9 does not belong to a set A. So this sign here is a sign of not belong to or not a member of. Do you now understand this better? So which means when you want to use this symbol, use it for something that's a member of, something that belongs to a set. While this one refers to something that do not belong to that set, or it is not a member of that set. The number of elements in a set. So I want to look at how do we calculate the number of elements in a set? The number of elements in a set are normally written as number of that set. Let me say set A. If our set is A, and we want to know the number of the elements in that set, after getting the elements of that set, you now calculate that number, each of the elements one by one. What are we talking about? Example 2. If W is equals to whole numbers between 2 and 10, whole numbers between 2 and 10, we know what whole numbers are. Whole numbers are numbers that have no decimal points, without decimal points. So between 2 and 10 means 2 is not included, 10 is not included. We start from 3 and we end at what? 9. Now, let us list the elements of the set W. Whole number between 2 and 10. We have 3, 4, 5, 6, 7, 8, 9. So these are the elements of W. But what we are asked to find is to find the number of W. So number of W will be by counting individual number. 1, 2, 3, 4, 5, 6, 7. So the number of W equals to 7. So this is how to calculate the number of the elements in that set. So if you enjoyed this class, kindly subscribe to my channel and click the notification bell for you to be getting my subsequent content as we move on this topic. And don't forget to share, like, and also leave a love emoji so that other learners can also benefit from these contents. The next subheading we're going to be talking about is the equal set. The word equal, we know one set will be equal to another, meaning the elements in the first set will be exactly the elements in the second set. But one element might be repeated 2 or 3 times, yet they are counted as one. Now, let's take an example to illustrate equal sets. As I explained earlier, that is, when two sets have the same elements, either being repeated or not, which say they are equal sets. Now, example 3. If S is equals to B, A, D, C, which of the following sets are equal to S? Question A. Set P equals to B, A, D, C, A, D. According to what we have here, is set A, is set S equals to P. Let's check very well. We have B here, we have B in set S. We have A, we have A. We have D, we have D. We have C, we have C. You can see that all the elements in S are also in P, though set A, element A is being repeated in P. Nevertheless, we count it as 1. Element D is being repeated twice, we still count it as 1. So in this case, we say that set P is equals to set S. All because all the elements in P can also be found in S. Okay, what of the second one? Q. In Q we have element D, element D, element A, element A, element C, element C, element E. There's no element E here. But we have element B here, we don't have element B here. So which means that element E does not belong to a set S. Because E does not belong to a set S, this means that set Q does not equal to set S. So this Q does not equal to what? S. The last one, first 4 letters of the alphabet. We must first of all write the letters out. First 4 letters. And when we say first 4 letters of the alphabet, talk about A, B, C, D. Don't forget we use small letter to write elements of sets. Now, let us now compare. Let's compare these elements with this S. This is A, we have A, B, we have B, C, we have C, D, we have definitely element set R. Definitely set R belongs, definitely set R is equal to set S. R is equals to S. So set R equals to set S. So we've come to the end of this class. If you are a new member that is just joining us for today and you find this class so interesting and enjoying, please kindly subscribe to my channel and click the notification bell for the subsequent content we are going to be releasing so that you can enjoy the more. And don't forget to share, like, and leave a love emoji so that other learners can also benefit from this interesting class. I remain your tutor, Lateef Ismaila Akambi, your mathematics and chemistry tutor. So watch out for the next lesson in sets.